Okay, here's the question, A, B and C. And there's also part D, which I'll go scroll down to now. There it is there. I've summarized the question over the page here, so let's have a look at it then. Find dy dx. It just has one single stationary point, M, on this curve, and the point P is on the curve. Okay, find dy dx. Constant goes to nothing, x goes to 1, there's two lots of. X to the minus 2 this is, so the minus 2 comes up to make it plus 16, x to the minus 3, which is 16 over x cubed. So there's dy dx. Show that the normal at P is this. So when x is 2 then, so this is B at x equals 2, dy dx is equal to 2 plus 16 over 2 cubed, which is 8. 2 plus 2 is 4. So the equation of the normal at P, y minus 8 is equal to the gradient, which will be minus 1/4, won't it, for the normal? Because these products must give minus 1. X minus the coordinate of P is 2. Okay, so let's move the 4 up then. So 4y, and then 4 minus 8 is a minus 32 is equal to minus x, run the minus through, and then plus 2, isn't it? So what have we got? We want move the x over, x plus 4y, so move that over there, leave the 4y as is, move the 32 over to get 34. That's what we wanted to show here. Part C, show that the stationary point M lies on the x-axis. So part C, dy dx then equals 0, and find the x value. Well, that tells us then that 16 over x cubed is equal to, move the 2 over to minus 2, then move the x cubed up, read from right to left, and move the minus 2 down, 16 over minus 2, minus 8, cube root both sides, x is equal to minus 2 then, isn't it? So that's what we've got. X equals minus 2, so what does y equal? Well, here's the curve, 6 plus 2x minus 8 over x squared. 6 plus 2x minus 8 over x squared when x is minus 2. 6 plus 2 times minus 2 minus 8 over minus 2 squared is 4. So we get 6 minus 4 minus 2 is equal to 0. So part C, show that the stationary point M lies on the x-axis. Yes, it does. So M has coordinates then. Let's just write them down. The x coordinate was minus 2, wasn't it? And the y coordinate is 0, which we've shown that, part 1. Let's have a look at part 2 then. Hence write down the tangent to TEM. So the tangent, part 2. Tangent at M. Well, it's a stationary point, so if you think about it, it's going to be here, and it's going to be a stationary point of minus 2, 0. And it's dy dx is 0, so the tangent will just be the y equals 0 line. Okay, that's the tangent. Now part D. It said to write it down, which we did. Part D, the tangent at M and the normal at P meet at T. Find the coordinates of T. So the normal at P, x plus 4y equals 34. So x plus 4y equals 34. Y equals 0 then gives, okay, x is equal to 34. So T has coordinates then, 34 and 0. And that's the coordinates of T.